Welcome to Section 3 for Part 6 of the OwlBot project. Previously in Section 2 for Part 6 of this project, we ended the video with connecting a 0.1 microfarad capacitor across the terminals of the DC motor we're using. And we placed our JST connector sockets onto the daughter board we made to accept the connectors for the solenoids and connectors from the gates of the MOSFETs to the Arduino. Now that we have the capacitor across the terminals of the DC motor, we need to add some connectors to the ends of the wires coming from the motor so that we may connect it to our daughter board more easily. At this point, I'm adding a SYP-2Y connector to the ends of the red and blue wires coming from the DC motor. What I did was add a SYP female pin to each of those wires to then insert them into the red plastic SYP connector you see in the background here on the workbench. If you look closely, you can see that I also twisted the red and blue wires of the DC motor before adding that SYP connector for better wire management. What I want to do now is make an extension cable for the wires of the DC motor. The wires on my DC motor are only about 3 inches or so long, so I want to give myself plenty of slack to be able to reach inside the owl figure I'm using for the OwlBot to connect to the daughter board. What I did was cut about 12 inches of red and blue 24 gauge stranded wire to use as my extension cable wire for the DC motor. What I'm doing now is adding the XH female pins to one end of each of these wires. I'll place these into a XH-2Y connector socket, which will allow me to connect the extension cable to the 90-degree XH-2W socket we soldered to the daughter board in the previous video. As for the other ends of my extension cable wire, I'll be connecting a SYP-2A connector to the other ends of the red and blue wires, using SYP female pins on the wires to insert into that SYP-2A connector I mentioned. You can see in there that that part is all the way up against, there's a face in there, so this side is a little wider than this side. So you can tell that that little piece is farther in there. And I'll show a different shot in a minute about what the teeth look like. But this little part here needs to stick out and stay clear from inside the teeth. It all needs to stick out like that. And then you got your wire about 1/8 of an inch exposed. This is a little more. Put it all the way in till the sheathing. See, this is too long. I'm gonna have to cut this a little bit more. It only needs to be about 1/8 of an inch. See, that's a little too much. So I'll take a little bit off. A little tiny bit. And that'll go inside, and then the blue sheathing on this wire will need to go all the way until it goes just inside the first set of
teeth in there, and it's going to get wrapped by that one, and we'll see in just a second. Where the first set of teeth wrap on the sheathing, and it should look like this. Now this is this XH female, and that's, so the larger tangs here, if I can get the larger ones here, wrap around the sheathing, and then these shorter ones inside here, once they get clamped down, clamp on the wire. So that's that. This is the back end of it, and then the front end, I have the tweezers inside the hole. It's hard to see. And this tool, I'm using this portion here of the teeth. Now you can see that when I clamp down, this hole's a little larger, and you can see that there's inside, there's a face in there. If I turn it, you can see how there's this face in here. So this section is larger than this rear section back here. If I flip it around, that's this section here. So those larger tangs, or whatever you call them, will go in this part, and the smaller ones will go in this back part back here. Now, here's the wire I just made. It's just an extension where this connector here is going to connect to the motor, like so. So that connects to the motor, and then the other end connects to where our motor connection is, which is this connector there. Just like that. So that is going to be how that goes for the motor.
Okay, I seem to have skipped the part of recording myself making the connector cables for the solenoids, so we'll have to enjoy a post-filming photo, or whatever you'd call it, an image to make up for the absence of film. Just as I did for the DC motor, I want to create more slack and wire availability for each of the solenoids to be able to reach through the owl figure. What I did was cut about 8 inches of black and white 24 gauge stranded wire to use as my extension cable wire for each of the solenoids. I went through the similar process of adding XH female pin connectors on one end of each black and white wire for each solenoid, to then insert those ends into a XH-2Y connector, one black and one white wire for each connector, similar to what we did in making the extension wire for the DC motor earlier. On the opposite ends of each of the black and white wire pairs, I attached a SYP-2A connector, one connector for each black and white wire pair of wires, making sure that I twisted the wires for better wire management. The SYP-2A connectors are to connect to the red plastic SYP-2Y connectors I added to the ends of each solenoid. Once these connector cables are made for both of our solenoids, We can now connect them to the XH-2A connector sockets we added to the daughter board for the connection points for solenoids labeled X1 and X2 on the hand-drawn schematic. If you remember in the previous video of this project, we added 3 MOSFETs to the daughter board. And you may also remember that we put a XH-3A connector socket on that daughter board where we connected each of the pins of that connector socket to each gate of the MOSFETs. One MOSFET was for solenoid X1 labeled on the hand-drawn schematic, another MOSFET was for solenoid X2, and the other MOSFET was for the DC motor. I had labeled the points of contact of those gates as point H, point J, and point N on the hand-drawn schematic diagram. To be able to connect the gates of the MOSFETs to the Arduino shield board to pins 7, 8, and 9 of the Arduino, I need to create a connector cable to go from the XH-3A connector socket of the daughter board to the pins 7, 8, and 9 on the Arduino shield board. What I did was cut 3 equal lengths of yellow 24 gauge stranded wire, about 6 inches in length, and stripped each of their ends to expose the stranded wire. What I want to do is connect a XH female pin to one end of each of those yellow wires, to then insert each into a XH-3Y connector socket. This socket for the 3 yellow wires will allow me to connect them to the connector socket of the daughter board for the gate connections to the MOSFETs. As for the opposite ends of those 3 yellow wires, I'll attach a female DuPont pin to each. Then I'll insert each of those female DuPont pin ends into a 3-terminal DuPont connector socket. This will allow me to connect the other end of this connector cable to the pins on the Arduino shield board we're using to bridge the connection from the gates of the MOSFETs on the daughter board to the pins 7, 8, and 9 on the Arduino.
Okay, here's that wire I just made. This part here goes to pins 7, 8, and 9 on the Arduino side, and then this part here goes to this connector that we put on the board that corresponds to the points HJN, or the labels HJN on the hand-drawn schematic right here, H, and then J and N. So next is to do the power supply and the switches. Okay, next up is to put start getting the switches, or get the switches put together. This is the switch I'm going to be using.
Okay, I'm going to have to stop myself right there. Initially, I was wanting to use this neat double rocker switch, but in the end, I couldn't get it to work for me. I don't know what I was doing wrong, and I couldn't find any information for this type of switch, so I ended up using 2 separate rocker switches later. One switch controls turning on and off the Arduino board, and one switch controls turning on and off the DC motor and solenoids. I'll continue this clip though, because here I'll go over putting the connectors on the wires to attach the switches, which will be the same for the switches I end up using.
This is double rocker switch, single pole, double throw switch, 6 terminals, 3 for each switch, and they light up when they're on, or they're supposed to. Because I plan on installing this on the outside or the body of the owl, that we're using here for this OwlBot project. And this, what I'm going to have this do, since it's two switches, one switch will control the power to the Arduino, and the other switch will control the power supply for the solenoids and the motor. So the switch for the Arduino will power it on, and that will allow power to get to not only the Arduino but to the LED eyes and the MP3 player. And then this switch, like I said, will allow the second power supply to be turned on to power the motor and the solenoids. And what I'm going to use are these little spade connectors to allow me to slip them on and take them off. These are large ones, and what I'm going to do is I'm going to use a 20 gauge, using 20 gauge wire for these switches because it's just a little bit bigger wire than I've been using. And I've already got one done here. This is obviously way too big for it, but that's what I have available right now. I took the 20 gauge wire and I got about, I don't know, 10 to 12 inches of it, and I took about 1.5 inches of sheathing off the end, and I twisted the end of the wire, and then I folded it in half to give me a little bit more meat to put in there, and then I clamped it down with, not that one, I clamped it down with this tool here. So I'll perform that real quick. So I got about 10 or 12 inches of 20 gauge wire. I stripped about 1 inch or so off one of the ends of the wire that exposes it. I twisted it around. And what I mean about to give myself a little more meat is now I'll bend it over like so, and that makes it a little thicker. And I'll take one of these spade connectors and I'll shove it up in there. I might need to bend it over a little more. And I'll stick it in there. And I won't shove the red sheathing all the way in because I don't want to clamp that down. I want to clamp just the wire part down. And I'll take this tool and I'm going to use the blue dot part, which is the middle section of the tool. And I'll rest like that. And I'll clamp down on it. You can see like this. I'll open it up and you can see I only clamp down that center section of that connector here. And that's what it looks like. And hopefully it's good and tight in there. And that's what it looks like. These happen, I thought these might be like heat shrink tubing on this, but it's not on the ones I have here, so it's just gonna be like it is. Again, this is not the proper wire and the proper connector you'd use for this size of wire, but I wanted to use this type of switch for what I'm trying to do, and they require these type, and I didn't want to solder them on. I wanted to have these connectors, so this is just kind of what I'm having to do here. You can use whatever type of switch you want and whatever type of connectors you want. This is what I had lying around and what I wanted to use. So I'm gonna get all this put together, and then I'm also, before I get to it all, what I'm gonna do is, now for the Arduino and the 9-volt battery for the Arduino, I'm using this type of connector. You buy them like this. I just happen to have cut this in half, but one end has the snap connector for the 9-volt battery and the other end has this barrel jack on it, and it comes together, but I cut it apart to expose the wires inside. And what I'm going to do is I'm going to put the switch in between for one of the switches, and I'll connect the wires in a way where they go to this switch, and they also will go to this barrel jack. And I'll show you on the schematic here. So here's one switch set up. This is the one to the Arduino. That's the barrel jack. And this is the switch I'm going to be using. So I'm going to take one of the terminals of the switch, and I have to be sure to put an image of this type of switch to show the proper orientation later in editing. But I'll take this terminal of the switch, and it goes to the red wire of this barrel jack. That center terminal will go to the positive supply of the 9-volt battery, and then this terminal will go to ground, but also to the black wire of the barrel jack. And then the other switch I've drawn here, I needed to put it in between the positive supply of the second 9-volt battery supply that we will be using, and that was the AA batteries, the 6 AA batteries we're using as our secondary 9-volt battery supply. That middle terminal goes to the positive supply of that 9-volt battery. We have this top terminal here going to the common ground, and this other bottom terminal here going to the positive supply to our smaller board that we just created with the MOSFETs on it. And then of course we need to connect all of the common grounds together, going all connected to each other, going to the Arduino, to the common ground of this switch, the common ground of this switch, and the common grounds to our board to the Arduino that we created in the beginning. Okay, I ran into a little issue here. I know it looks like a mess right now, but everything's hooked up as the schematic, as the hand-drawn schematic shows. Everything's hooked up the way it should be. We're at the point where we're testing it, and I was testing it earlier, and one of the solenoids wouldn't come on. So here I'm gonna start up the circuit. I'm gonna turn on both switches. I have one off. There's one switch that's over here. You can't see it, and I don't want to move it because everything is kind of haphazardly connected to each other. I've actually got just a pin, a jumper pin wire, or a jumper wire with a pin at the end of it inside the barrel of this barrel jack. And then I have this other white jumper wire with the alligator clips around the outside of that barrel that's going to a ground pin, or the ground pin for this barrel jack female end on the Arduino board. That's just because I needed to hook up the switch and see if the switch is gonna work, how well the switch works in the setup that we have here. But anyways, beyond all that, I wanted to show first, I'm going to turn the switch on over here that's out of camera view, and then this is the other switch that controls the secondary battery pack that powers the motor and the two solenoids. There's a solenoid here, and the other solenoid, I don't see it. Oh, it's right here. So I'll put one solenoid here, and this solenoid is over here, so we can kind of see them separately. But one of them won't come on. Everything else works fine, but one of them won't come on. So I'm going to turn the switch over here on. It's just out of camera view. Now we see the blue light on the MP3 player. We can't see the lights on the Arduino because the board that we put on top here. So you can hear it going now. This solenoid is firing. I know you can't see, but the DC motor is firing, but this solenoid is not firing, and it is hooked up. It's this one here, the kind of the center connection in the middle of the board on this. So this connection here, it goes to this solenoid, and this connection here goes to this solenoid, which is the one that's not firing. So I'm going to walk you through the steps that I went through to figure out why it's not firing. So let's do that next. So the first thing I thought of checking was, am I getting power to the board? Well, I know power, or the main power, is getting to the board because this solenoid is firing, the DC board, or the DC motor is firing, and signals from these three wires here that we had connected from pins 7, 8, and 9 from the Arduino going to our second board here that is our board for the MOSFETs that control the DC motor and the solenoids. I know power is going to there because the DC motor works, this one solenoid works. It's just this solenoid isn't working, which is connected to this connector right here in the middle. So first I thought, okay, or second, I thought, okay, is the wire that's connected to one of the pins from the Arduino that's programmed to fire each one of these solenoids and the DC motor, is there a signal getting to or through this wire? So to check that, I needed to get my multimeter and use the continuity tester on that multimeter, or on the multimeter, and first I would check that. So let's do that. Okay, so what I've done is I've removed this connector that comes from our Arduino to this board here, and these are the wires that are, this jumper wire is connected to pins 7, 8, 9 from the Arduino to our board as we had walked through during this whole build phase. Those pins are the ones that will control when the solenoids and the DC motor will fire. So that's what this connector's for here. And I want to check for continuity through these wires that will tell me whether or not there is a power signal coming through each one of these wires. I'm just going to check each one of them. The pin that I'm really focused on is pin 8 from the Arduino, which controls this connector here, which is the connector that goes to the solenoid that was not firing. But like I said, I'm going to check each one, and what I'm going to do is I've got the power turned off to the motor and the solenoids. I've got this 3-wire jumper wire connector removed from that board, And I'm going to turn the switch on that's off camera over here, over this way. That is the power switch that will turn the Arduino on. So that's the only thing that I want on right now. And again, the Arduino and the power to the Arduino will only power the peer sensor, the LEDs that are off over here, and the speakers. So right now we can see that the lights are flashing, which means everything is on. Oh, I forgot to also mention that I have the negative wire, or I have the common from the multimeter connected to this red jumper wire that's going to the common ground that I have right here that goes to the Arduino. And I'm going to take the red lead probe that's going to the multimeter, and I'm going to use it to connect to each one of these pins here. So as this is going off and it's making noise, that means that there should be signals firing to each three of these pins. Oops. I said continuity, but what I want to do is check for the voltage coming through. So we can see that there's a signal. Okay, right now it's off. If I make a movement here and let the peer sensor sense me, okay, we see there's a signal to that pin. I think this is pin 9, so I'll be working backwards. I'm in the middle pin now. We can see that there's still a signal going to that jumper wire, or the center pin. Now there's nothing because everything is stopped. So if I move again, we can see there's a signal going to the center. Now I'm going to go over to this left, to my left, which I think is pin 7, and it has a signal as well. So that tells me that there's a signal going from pin 7, 8, and 9 to this jumper wire. So the signal coming from the Arduino through the end of this connector on the jumper wires is working as it should. So I know the issue is not there. So I'm going to work my way to the next step. Okay, we just checked to see if we're getting a signal at the end of our jumper wire from the Arduino here. Next, I'm going to check the board itself. And to do that, I'm going to first remove the DC motor and both solenoids from these connections on the board. And what I'm going to do is I'm going to check for continuity on this board. And I want to check for, first I'll check the continuity for this MOSFET, and this MOSFET is associated with this part of the board, and this is the connector that was working for this solenoid back here, because that's where I had it connected to on this one. So what I'm going to do is I have my multimeter set to continuity, and I'm going to take my probes from the multimeter. I'm going to move my multimeter kind of out of the way because I'm going to need to have something hold this board for me so I can have you see what's going on. Okay, now I have a little closer up, a little bit more of a close-up view of this board. And what I want to do is I want to check for continuity. I'm starting on this section of the board because this section here is the connections for this MOSFET here. This section here is for the connections for this MOSFET here. And this is the section that is in question. We want to know why when we have one of the solenoids plugged here, why it's not firing. And I should mention, and I didn't do this, I had each solenoid plugged in. This side was working, this side was not working. I even took out the solenoids, disconnected them, and I switched them around. I tried one after the other, and both these, no matter which solenoid I plugged in here, it worked. No matter which solenoid I plugged in this connector here, it would not work. So this is the section in question. I know that doing the switching around told me that both solenoids do work. It's just when plugged here, neither one of them would fire off when everything was powered on and working as it should be working. So here I want to check for continuity from this jumper wire that's here. Again, I'm just checking on the side that actually works right now. Actually, I'm going to go, because that jumper wire is connected to the anode of this diode here. I want to check this side, which is this right pin here, and it should be connected in parallel with this. Both of these pins are connected in parallel with this diode, and the right side is connected to this anode side of the diode, and this left pin is connected to the cathode side of the diode. So I'm going to check this right pin and the cathodes or the anode side of the diode, and we can hear there is continuity, or it is connected to each other, which is the way it should be. And the diode is connected, or the anode of the diode is connected to the drain of the MOSFET. And I have checked for continuity there, and that is connected the way it should be. And I've also checked, even though I'm not going to do it right here because the viewing situation is not that great, but there's a jumper wire here, this little yellow one in here, that connects from this pin to, that makes the connection from this pin on the right through to that little yellow jumper wire to this anode of the diode. And having that continuity means that that connection is the way it should be. And now this left pin here on the connector is attached to, or connected to, this yellow jumper wire, which is connected to the cathode of this diode, which is the way it should be. And if I touch this, the cathode of the diode and that pin, we have continuity. So there is a connection there, and that's the way it should be. So this again is the side that does work. This side should be similar to this side. This pin, this right side pin here, is connected to this yellow jumper wire, which is connected to the anode of this diode. So there should be continuity between this pin and the anode of the diode. And there is. Similarly to this side, this left side pin is connected to this little yellow jumper wire, which is connected to the cathode of this diode, and there should be a connection between this pin and the cathode of this diode. And if I touch them two, we have continuity. So that's telling me that those connections are the way that they should be. And I've also tested for continuity across other connections on the board, and everything seems to be okay. Just doing kind of a general continuity check for different connections, even from this 3-pin connector, which is for the connector we just checked earlier. And that's for our signals coming in from the Arduino going to each one of these solenoids and into the motor. And all that seemed fine as well, both on the connector and from the connector here on the board. So now I'm kind of just working my way through even further to test and see what's going on and where this issue is. for the reason why any solenoid plugged into this connector is not firing. So let's go to the next step of this process of determining what's going on. Okay, so the next thing I want to do is I want to flip this board over, and I want to continue the process of trying to figure out what's going on. So now with the board flipped over, I'm going to go through a similar process that I did when I was checking this connector here. In the beginning, I'm going to plug this into this board. If I can reach here. Okay, I've connected that to the board. See if I can't move that. So you can just see back here, I have that 3-wire jumper wire with that connector on it, and it's connected to the 3-pin connector on the other side of the board here. And those are for pins 7, 8, 9 from the Arduino. And that controls the signals that we did encode on the Arduino, that when the peer sensor goes off, it sends basically pulse signals to the 2 solenoids and to the DC motor. So what I want to do now is I want to check that now that that jumper wire is connected to the connector on the board, I want to check and see if those signals are making it to the gate of the MOSFETs. And I'm going to check all the MOSFETs just so we can see what's happening. So I know it's hard to tell here, but these 3 pins here are for the MOSFET that's for the DC motor, and then these pins here and these 3 pins here are the MOSFETs for the 2 solenoids. And this is the MOSFET in question here, where that solenoid was plugged in at and it was not functioning properly. So I'll check the motor, the gate of the motor first, and then I'll check the gate of this MOSFET that's working, and then I'll check the gate of this MOSFET for the one that isn't working for us right now. So I have my multimeter here, and I'm going to try to put it somewhere where we can hopefully see it. I guess that's about as good as that's going to get right now. I have it set to 20 volts right now, and I'm going to turn the power on to the Arduino. And what I'm going to do is I'm going to take my black probe, which is connected to the common of the multimeter, and I'm going to probe this on the common ground of the circuit, which right now is just to the Arduino. I'm going to take the red probe of the multimeter, and I'm going to first probe the gate of the MOSFET for the DC motor. So again, I'm going to make sure I'm getting the power to the Arduino. There we go. So power is on, and right here is where the gate is to that MOSFET to the motor. And if there we go. Okay, we can see on the multimeter in the background that it's getting a signal. So that seems to be okay. So that signal from one of the pins from the Arduino, and that's from pin 9, I believe, is making it to the gate of the MOSFET for the motor, and that's what we want. Next, I'm going to check the gate, which would be from pin 7 of the Arduino, and we can see that there is a signal showing up on the multimeter here. So that Seems that everything is okay there. And now I'm going to touch the gate of this MOSFET here that controls that was controlling the solenoid that wasn't working for us earlier. So I'm going to touch that gate now. Try to get it to... Now it's showing me that there is a signal right now. So it seems to be okay, but if I can get my hand in a way that's not in the way of the multimeter. Earlier, I was able to probe it. I'll move this a little closer. Earlier, I was able to probe it and I wasn't quite getting a signal. It was kind of finicky. Doesn't seem to be that way now. Let's see if we can get it to... Seems to be working now. Earlier, I wasn't quite getting a signal, even when I was touching the pin of the MOSFET. So if I turn it over, and touch that, I'm going to touch the drain. I'm going to have to turn it sideways here. But you see back over there where the multimeter is, there's nothing happening. And I'm touching the gate of that center MOSFET here, this one here. That gate is on this pin on this side, on this face of the MOSFET. And you can't see it in the camera, but I'm touching the gate for that center MOSFET. You see the multimeter back there? Nothing. If I touch the gate on this MOSFET, we can see something happening. If I can get on it, I'm not touching it. We see that there's a signal to the gate of that MOSFET. If I touch the gate of this MOSFET, nothing. Not getting hardly anything. If I touch the, well, I can't reach down in this one, but let me put this back. So let me try again now that I have it flipped back over. I think we can just see that. Okay. So again, this is that gate pin. I'm touching it, but I'm not getting anything. If I touch the gate for that one, we can see that we're getting a signal. That's for the solenoid that was working. This is for the DC motor. We're getting a signal to it. I touched the gate for this, for the MOSFET that wasn't, it seemed that the MOSFET that wasn't working for us, I don't know if it's the MOSFET or not yet, but if I touch the gate of that MOSFET and let we see that, okay, now we're starting to get a signal. It seems to be finicky. Like sometimes I get a signal, sometimes I don't. Now I'm not getting it. But if I touch where the jumper wire is that's supposed to go to that gate, and that's where the connection from the resistor to the gate and the jumper wire to the gate and the jumper wire that comes from the connector for the solenoid that goes to the gate meet and goes to the gate to the MOSFET. I get a signal there, but sometimes I don't get a signal at the gate pin. Like right now, I'm touching the gate pin right now, nothing. If I touch the jumper wire to the gate and to the resistor to the gate, I'm getting a signal. So that tells me that there's no real connection between the gate, or there's not a solid connection between the gate pin and the resistor to the gate, or the pin from the solenoid to the gate, that all of that goes to ground. There's not a good connection there to the gate. So let me give you a close-up if I can. So I know it looks awful, and this is kind of an awkward position for me. There's the multimeter. This is the gate pin. Nothing. But this is the jumper wire, and then the resistor that's supposed to be connected to the gate pin, that I'm still receiving a signal. If I move a little bit and let that go again, that's the jumper wire that comes from the pin of the connector that goes to the solenoid. There's a signal to it. It's supposed to be attached to that resistor. There's a signal to the resistor to ground. But this point here is supposed to be connected to the gate pin, and there's nothing happening. Nothing. So I'm thinking that that's our issue. There should be a connection between here and here. The connection where the resistor and the pin to the connector that goes to the solenoid connect to the gate pin of the MOSFET. I'm thinking the connection here, there's no connection here. So let's deep dive even further, and I'm going to connect the solenoid just to here, and I'm going to make a temporary connection with this probe to see if we can't get that solenoid to fire. Okay, I've zoomed out, and I've got a solenoid here. It doesn't matter which one I get. I'll reposition in a minute, but I'm gonna connect it to where we're testing at to see what the problem is, which is this middle connector here. That's the one that was not working earlier. Okay, it's connected in. Here's our solenoid, and I'm going to turn the power on to the Arduino. Again, that's off over here, off the camera here. Okay, we can see the light flashing on the MP3 player, so that everything is on. Now I'm going to turn the power to the solenoid on. So right now I have power to everything. And again, I'm going to test. I got the multimeter back here. We can just see it. I'm going to test the probe or the gate. Nothing. But you can see that if I accidentally touch across the gate and that jumper wire, that now all of a sudden that solenoid's firing. So that, again, that means that this jumper wire here, that on the other side of the board that attaches to the pin, one of the pins that go to the connector for the solenoid. So that tells me that goes to one of the pins on the solenoid, means that there's not a good connection between there and the gate of that MOSFET. So now if I'm making the connection with this probe here, we get the solenoid back here to start firing off. If I let go, it stopped. If I touch it again and make the connection with this probe, it's working. So the easy fix here, I want to turn all this off. So the easy fix here is I just need to make a better solder connection between that gate pin and where that jumper wire meets that gate pin, and then everything should be working. So I'm going to do that real quick off camera, and then I'll come back with everything hooked up and see if both solenoids are working and the motor working and everything else is working. Okay, I'm back. I have everything set up. I know it's still a mess and you can't tell anything, but all we're doing here is trying to check and see that after all of that, trying to figure out what the issue was, why this connector or the solenoid connected to this center connector here wasn't working. We're now at the point where we can test to see if our findings were correct. So I have both solenoids over here. They are connected to this board, and I have the DC motor here, and I added this little piece of paper here to make it easier to see when it's spinning. And then the two LED lights are down here, and we can see the speakers here. I have the Arduino set up on its end here because I've made these temporary connections for power to it, and I have the switch that controls the Arduino right here, and the switch that controls the power to the motor and the two solenoids from this power source here. That switch is right here, and the power source for the Arduino is right here, this 9-volt battery. So I kind of have everything kind of jerry-rigged up here. This is all for testing purposes. We're now not only wanting to test the circuit as a whole, but we want to test to see if that issue that we had earlier with the solenoid not working, if that has been fixed by our findings. So I'm going to turn the power on to the Arduino. Again, because it's standing up on its end, we can't really see the light unless you can see it in a reflection over here somewhere. The blue light from the MP3 player. The LEDs are coming on right now, but I have not turned the switch on to the motor and the solenoids yet, so I'm going to turn those on, the power on to those. You can see the DC motor, and both solenoids are firing off now. So we've fixed that issue. We've fixed that issue that we had on this connector here. So now everything's working as it should. So we can see both solenoids firing off, the DC motor going, the two LED lights blinking, and we can hear the owl sound on both of the speakers. So everything seems to be working as it should now, which is great. Okay, I made some changes from the kind of switch I was using. Instead of using the 3-prong switch, I'm using a 2-prong switch now. Connections are basically exactly the same as they were, but for the 2-prong switch, I have one of the prongs. This is just a single pole, single throw rocker switch that I'm using for both switches. So we have one terminal going to, in this case, the red wire of the barrel jack that we're using to plug the 9-volt power, the 9-volt DC power supply to the Arduino to power that. And then we have the black wire coming from that barrel jack going to the common ground and also to the other terminal of that rocker switch. And then the second rocker switch controls the power from the secondary 9-volt battery power supply consisting of the 6 AA batteries that we're using to power the DC motor and the two solenoids that we're using. And that rocker switch is connected in between that positive 9-volt battery supply and the power going to our board here that's set up for all of the components that we need that controls the solenoids and that DC motor. So this is the rocker switch for the power coming from the 6 AA batteries for the 9-volt power supply going to the DC motor and the two solenoids. And then this rocker switch here, it controls the power, the 9-volt battery that powers the Arduino. And the smaller electrical components like the two LEDs and the MP3 player that's on the board that we made attached to the top side of the Arduino, and the two speakers, and to the peer sensor that's right here. I'll move that so we can see it a little better. But that's the only update I did to this whole thing. Was I'm using the two rocker switches to control the two different power supplies that we're using for our owl supply circuit. Okay, I just needed to mention that I ended up changing the switches, and these are the switches I'm using. This one is for the one that goes to the Arduino, and this other one is the one that goes to for the power connected to this board here. That's this 9-volt battery power supply here, made up of 6 AA batteries. So the switch here controls this power supply, and this switch here controls this power supply, this 9-volt battery, to the Arduino. And I just decided to change to these just basic 2-terminal rocker switch for both, to control both power supplies. And in doing so, that meant taking one of these ground wires off that I had put on recently. That's just the minor modification I had to do, besides creating new connecting configuration to everything else, which I'll show you how those switches are connected next. Okay, here's sort of a top view of everything, or almost everything, at least the view for the switches. So this is the switch, the red color, the red lettered one, which controls just switching on and off this 9-volt battery that's connected to the Arduino and our board that we made for putting on top of the Arduino. So all I did was use one of these 9-volt battery snap connectors with the barrel jack end on it. I cut it in half, and when you cut it open, there's just 2 wires in it. There's a red wire and a black wire, and that's this here, and the other end goes, the snap connector ends on the battery. So I took the red wire in here, and I have a white wire that I soldered to the red wire to the snap connector end, and that white wire goes to one side of the switch. The other side of the switch has a red wire connected to it that goes to the red wire on the barrel jack end, which is currently plugged in to the Arduino. So that's all that's controlling the Arduino. So next, there's the black wire that comes from the snap connector to the 9-volt battery, and it's just still connected around to the barrel jack that is connected to the Arduino. So that's all there is to this particular switch here with the red lettering that I have here. This one controls this power supply here for the Arduino, and everything connected to the Arduino, which would be the MP3 player, the speakers, the peer sensor, which you can barely see here, and the LEDs, and that's it for that side. Now for this white letter switch here, it's the same type of switch as this one. It just has white lettering instead. And again, I'm using a 9-volt battery snap connector for this particular configuration. And this is just a different type. It's just a basic type that already has the red and black wire exposed on it. I took the red wire and I connected a white wire to it, and that white wire goes to one terminal of the switch. The other terminal of the switch has this red wire that I've connected to it that is connected down to our positive supply for this control board that we made that controls the power to the MOSFETs and the DC motor and the two solenoids. The DC motor is kind of off camera here, but it's over here. And then the black wire coming from the battery supply goes around here and to the grounding point of this control board here for the motor and the solenoids. And then of course we have this other black jumper wire that goes to the common ground that we made going back to this board on top of the Arduino. So that's it for the switches, at least the update on the switches that I did for my switches. You can use whatever type of switches you want. This is the configuration I ended up choosing. So next we'll take a look at the finished product, or at least for the circuitry for the OwlBot.